Okay then, part 2. Okay, going to be showing you how to measure voltage on a multimeter, specifically a DC voltage. Now then, take you through running through on the Beckman DMM. Okay, and to measure voltage on this, what you need to do first is to set it to measure a voltage, and it's written on the front DCV. Just here, okay, DC voltage, and turn it on. Done. Okay. Now on the Beckman, okay, it's got a range. Okay, just here, voltage range. This actually shows you the maximum what the multimeter can measure up to. Okay, this is actually its maximum. So if it's set to, I don't know, 20. Okay, DCV 20, it can measure up to 20 volts maximum. Okay. Good things and bad things with it. The bad thing is it can only measure up to 20 volts. If you go above 20 volts, you need to change the range and move it up to the next range up. If you're measuring very low voltages, okay, to the bottom end of its range, you may have a couple of, you'll increase the error in reading. Okay, so you might want to move down the range to get a little bit more accuracy for measuring lower voltages. So this one's currently set to, let's set this one to, I don't know, say 2. Okay, can measure a maximum of 2 volts. Let's set up the multimeter to measure voltage. Simple. Down the bottom you've got a couple of sockets. Okay, the ones that we're going to be using it. COM. Okay, you measure everything with reference to common. It's the black socket. One next to it is your voltage socket, and you know it's voltage because it's got a V written next to it. Simple. So, proper probes. All multimeters come with probes. Okay, just like oscilloscopes, you've got multimeter probes. These sockets are 4mm sockets, so if you don't want to plug in probes, you can always plug in the 4mm banana plugs. Okay. Now multimeter probes, okay, they haven't got any attenuation like oscilloscope probes do, but the one thing that you want to look out for, make sure that they've got nice sharp points. Okay, because that way when you take your measurement, plug them into the circuit, okay, you apply a lot of pressure to the point, so you get, because it's a point, okay, pressure increases to the point, physics, okay, and you'll take a good reading and they won't slip either, okay, because they're quite sharp. So, take a multimeter leads, black into black, red into the red socket. Okay, and let's take a reading. Alright then, so what I'm going to do is take a reading of a power supply. I've got a DC power supply here, triple output. We're just going to use one side of it, okay. You can go from 0 to 30 volts, the maximum current rating of 2 amps. So let's switch it on. Okay, so it's set to 19.6 volts. Won't bother setting the voltage on this just yet, we'll just plain read that. So all that you need to do, take your probes, red to red, black to black, and we'll take a reading. Now at the moment it's showing minus 0.00 something volts, okay, so it's definitely nowhere near 19, that's because it's not on. Switch it on. Now this is 19.6 volts output. Now we're on the 2 volt range, so it's over range and it's actually displaying a 1 on here. On here it's 1 dot nothing, then it's over range. Okay, it's overload. And what you do is you move it up to the next range, and hey presto, there we have it. It's actually 19.6364. Okay, and that is our voltage reading. Okay, like I said before, if you're on a range that's too high, you lose accuracy, so I actually think that it's 19.6, maybe 19.7. It's fluctuating because you've got this extra digit that's unknown. It's beyond it's beyond the range. Okay, so it's actually oscillating around that 0.6. It doesn't know whether it's above it or below it. Okay, this power supply is probably outputting maybe a little bit more, maybe that a little bit less than 19.6, and maybe the multimeter thinks that it's slightly more, slightly less. Okay, you've got an error in your measurement, and it's fluctuating around the value. Change it back, and there we are. Okay, very simple, taking measurements, DC measurements. That's all there is to it. Okay, now then, moving on to the next multimeter. Okay, got our second multimeter. It's always useful to have two multimeters. Okay, maybe two of the same type. Okay, so you can get an idea for accuracy. Okay, if you think that you've got a strange reading, it's always better to take a reading on a second meter. Okay, just like it is on an oscilloscope. You get a very odd reading, you think the oscilloscope's affecting the circuit. Okay, with the circuit or something like a reading, it doesn't look correct, so scrap another instrument. Okay, multimeter is particularly important. Okay, for that reason, we always have two multimeters. Okay, now you usually have two of these ones in the lab. But you may not, you may have this one and you may have the Beckman one. Okay, so it's always good to use two different ones, but like I said before, they do measure slightly differently, but slightly different range. Okay, and we'll be covering that later on when we do current, because that's when it becomes apparent. So, measuring voltage on the fluke. Okay, move the dial around to measuring DC voltage. Okay, voltage with the barred dotted line. Okay, representing DC, so DC volts. Now on this one, there's no actual range for you to select because this is actually auto ranging. Okay, when you initially switch, it only goes into auto range. It will detect the best range and it will switch to that particular range. If you want, you can hit the range button at the top and you can manually set the range if you want. Press it a few times and it will slide the decimal up and down the display and give you various displays. Okay, and this can measure down to 1 millivolt and up to, it says it on the bottom here, 600 volts. Okay, this is 600 volts DC, so it'll be 600 volts RMS. Okay, if it was AC that you're plugging into it. Same with this one, it's actually quoted down here. The actual maximum is 1000 volts, 1 kilovolts DC. Okay, and if you take a look down the bottom, it's actually got a reading for 750 volts max for AC. So always pay attention to the maximums. You don't want to plug in too much voltage, otherwise you can damage your instrument. And let's take a reading with this one, just like the other one. You've got your probes. When it comes to DMM probes, unlike the oscilloscope, which uses usually uses a BNC connection, and the BNC is a BNC connection world over. Okay, multimeter probes generally they come with proprietary connectors, so these ones are quite long compared to and they're actually screened compared to the Beckman ones, which are a lot shorter, and they're unscreened. So these ones won't actually fit into the Beckman meter. And these ones will fit into the fluke, but because they're a lot shorter, they may not give you a very good connection, so it's best to use the leads that come with a meter, or, like I said before, all multimeters have 4mm sockets, so you can use these as well. Okay, so they're universal. The multimeter probes aren't. Okay, they're designed for that particular meter. So like before, red into red, black into black. And unlike the Beckman ones, they've both got sharp points, but these actually a sharp point which goes to a 4mm plug. So if you've got a 4mm socket, these fit nice, snug and tight into the socket, and you don't have to hold them in place, they'll hold themselves in place, which is really good. Okay, so ready to take a measurement. I just noticed that I made a mistake. I'd actually plugged the red one into your amp socket. Okay, be careful, the Beckman voltage is on the left hand side. On the fluke, the voltage measurement is actually on the right hand side. Okay, if you've been using the Beckman, you can make that mistake without even realising what you're plugging it into, because you get so used to plugging things into sockets. Okay, so you've still got your common socket It's still got your voltage socket denoted by V. Okay, it's got some other symbols next to it, resistance, continuity, capacitance, diode, etc. So if you wasn't measuring anything else, you'd use the same socket. Amps on the other side. Okay, just like the Beckman one, multimeters are more or less the same world over. Take a measurement, black to black, red to red, and hey presto, we didn't have to touch a thing, and it's given us a reading of 19.59. Extremely close to 19.6. Okay, so it's a reasonably good assumption, and that is the voltage that's coming out of this unit, and that's all you really need to know for measuring voltage, except your range. Okay, so you got your range button, like I said before, shifts goes into manual, press it again, changes the range. So like before, when you switch to 200 volt, okay, it shifted the range up, dot across, and it's done exactly the same for this one. And on that range, it's on a very, very low range, 0.7 volt, which is way below, so it's way over range. Goes into overload until you go into the correct range, which, there you go. So instead of a twisted dial, it's actually a push button, or when you reset it back into voltage, it goes into auto range, and that is what it is. Simple. What more do you need to know? Measuring voltages in circuits? Same thing, so let's do that. Okay then, I've got a circuit set up here, very simple one. Two resistors in series, a potential divider if you like. I haven't bothered picking out these values of resistors, just got these out of the recycle bin, so I haven't got a clue what the ratio is. But, let's do some measuring, okay? And I'll leave you to work out the ratio, and we'll just concentrate on showing you how to take a measurement in circuit. So we've got again 19.6 volts. Let's make this say 10 volts. Okay, nice value to work with. Okay, so we've got 10 volts in. Okay, let's take some measurements. Right, so whenever you build a circuit, first thing that you do before you even turn it on, or after you turn it on, whichever. Okay, well, what I do before you plug your circuit in is to take measurements of your voltages. Okay, but we'll skip over that. Okay, we'll leave that for circuit building. I'll do a guide on how to build a circuit. Okay, and basic running through on how to actually connect up stuff. So, concentrating on the multimeter, two probes, red and black. Okay, well, let's take reading. So let's slot it into our meter. We've actually got 9.99999 volts. Okay, so we've probably got a little extra digit back here, just rounding this off to 10 volts, which is slightly off the screen. This one's as close as it's going to measure. Okay, so it may actually be 10 volts, and maybe very close to 10 volts. Let's just touch the fine control. It's more or less around 10, maybe 10 millivolts out. It's not a biggie. Okay, you can call it 10 volts. So we've got our 10 volts going in. Into our breadboard we've got our same thing, our 10 volts. Okay, and down onto the circuit we've got our 10 volts. So red to red, black to black, following the colour coding. It's all the same. Excellent. We've got a voltage going across our two resistors. If you want to measure voltage across a single resistor, remember these are multimeters measure a potential. Okay, it's reference to common, not to earth, so you can actually measure in circuit between 2 points. Okay, you won't short out the rest of the circuit, unlike an oscilloscope where if you connect your common, your earth clip, okay, you actually can make that bit earth and you short out the circuit, but on the multimeter you don't have to worry about that. So across what's this, a 10k resistor, we've got 4 volts. Across our other resistor we've got about 5.9 volts, and that's all there is to it. You just touching the wires to the end. Okay, what you want to make sure though is that you actually connect them the right way around. So the side with the lowest potential, that's the side for your common. The side with the highest potential is your red. So red to red, black to black, as it were. You can measure through your circuit and so on. Okay. If you do it the other way around, what you end up with is a minus. Okay. So something that you want to be careful with. Okay. Make sure that you get your program the right way, otherwise your multimeter will measure in reverse. It's a piece of electronic equipment. It hasn't got a brain. It doesn't know what it's measuring. It just measures what you connect it to. So make sure that you connect it up correctly. Red to red, black to black, or red to the high side, black to the low side, so on. Okay. That's all there is to it. So if the circuit wasn't connected properly, say, so let's make an open circuit. Let's just pretend that we thought these were connected together. Okay. When you're measuring your potentials again, you'd have still got your correct voltage on the input, still got your correct voltage across your components. Yep. But when you start probing in the circuit itself, okay, you can see that it's actually, follows the voltage through to there, this is still 10 because it's open circuit. Okay, it's the potential of 10, it's not being dropped in it, you haven't got current flow. And across this one you've got 0 because there's no actual positive connected to this wire here. It's open circuit. Between the two, 10 with a little bit of a voltage drop, because you do in actual fact have a slight resistance in this, so you make a circuit when you connect to it, but not a great deal. Such a high value that you only get very minimal drops. It gives you an idea of whether things are connected together or not in terms of a voltage. Okay. So yeah, you just program the circuit, do whatever you want to do, and that's how you measure voltages, really. I won't cover measuring AC voltages. I'll leave that after I've done current, and we'll cover measuring AC current and AC voltage together.